Hello, my name is Corin, and for my final exam, I decided to discuss the methods of non-enzymatic browning and the emulsion formation as I make a caramelized onion vinaigrette. I was really intrigued by this recipe because I love caramelized onions and I'm always looking for new dressings to add a kick of flavor to my salads. I also think this dressing sounds like it can make a good dipping sauce for chicken or other sorts of meat. The ingredients that this recipe calls for are brown sugar, a yellow onion, olive oil, red wine vinegar, honey, Dijon mustard, and oregano. So to begin, the recipe I found calls for first the sautéing of one large yellow onion with 2 tablespoons of olive oil in a sauté pan over medium to high heat. To do this, I will first heat the olive oil and then add the onions and sauté them until they are translucent. What is happening during this process is a non-enzymatic browning. Caramelization and the Maillard reaction are both types of non-enzymatic browning. They do not have to occur simultaneously, however both occur when sautéing onions because of the compounds found within onions. Caramelization occurs when sugars interact with sugars, while the Maillard reaction occurs when sugars interact with amino acids. Onions contain sugars as well as amino acids, and therefore caramelization and the Maillard reaction occur when onions are sautéed. Caramelization is common when sugars are melted into syrup by heat. Not only is heat needed to begin this process, but heat is also given off through the caramelization process. The sugar sucrose is broken down into fructose and glucose, which are non-reducing sugars and are therefore able to give away their electrons as they are broken down when heated. This characteristic leads to their ability to form new compounds, which gives rise to colors and aromas. As with caramelization, the Maillard reaction also develops tasty flavors and aromas. In the Maillard reaction, heat allows carbohydrates to break down, allowing its carbonyl group to then bind with the amino group of present amino acids. When these react together, the Maillard reaction is occurring. Therefore, caramelization and the Maillard reaction are both functioning to provide the sautéed onions with good flavors and odors as new compounds are formed during these reactions. I continued to sauté the onions, and now they are beginning to have a translucent look. Now the recipe calls for the addition of 1 tablespoon of brown sugar while lowering the heat and continuing to let the onions sauté. This allows for further caramelizing of the onions. As long as amino acids are present, the Maillard reaction will also occur. Once the color turns a golden brown, the cooking of the onions is complete. I'll continue to sauté them until I get this color. Now that my onions are that golden color that I want, I'll remove the onions from the heat and allow them to cool. Now that the onions have cooled, I've removed them from the saucepan and put them in the mixing bowl. Now I will put them into a blender and pulse them until they're at a good consistency for my dressing. Now I have my onions to the consistency that I need them. I place them in a larger mixing bowl and will now add 1 tablespoon of Dijon mustard, 1 tablespoon of honey, 3 tablespoons of red wine vinegar, and 1 teaspoon of dried oregano, and whisk all ingredients together. Once I've initially whisked the ingredients, I'm going to slowly drizzle a half cup of olive oil into the bowl while continuing to whisk. What is occurring here is the formation of an emulsion, specifically a vinaigrette emulsion, which indicates that an emulsion is occurring between a vinegar and an oil, in this recipe between red wine vinegar and olive oil. The science behind an emulsion is that a homogenized state is formed between immiscible substances. When the immiscible fluids naturally position themselves to one another, they position themselves so that their surface tension allows for as little touching as possible. Naturally immiscible fluids form distinct layers. That is why distinct layers would be present if we did not whisk our ingredients. Emulsions occur when the surface tension between immiscible fluids is broken. This occurs when shearing power is used to break up the dispersed phase into the continuous phase. This can occur from shaking, whisking, or blending. In our case, whisking functions to break up our dispersed phase of vinegar into the continuous olive oil phase. In an emulsion, the substances combined maintain their individual characteristics. However, because immiscible substances do not naturally have an affinity for one another, an emulsifier is required to stabilize the emulsion. In this recipe, the emulsifier is mustard. Its addition stabilizes the emulsion by hindering the ability of the mixture to reform its distinct layers. This is possible because emulsifiers have a hydrophobic and hydrophilic component. These structural characteristics of an emulsifier function to stabilize the emulsion because its hydrophobic head favors association with our oil, while the hydrophilic head favors association with our vinegar. This prevents separation of the emulsion. Stabilizers can also be used to stabilize emulsions. However, they function differently than emulsifiers. Emulsifiers work to link the immiscible compounds, while stabilizers work by interfering with the dispersed phase of an emulsion to prevent coalescence. Stabilizers are typically water-soluble, and therefore they are used when the continuous phase of the emulsion is water. Because our continuous phase is oil, we use an emulsifier. I'm going to continue whisking until the compounds have been emulsified. Now that the components have been emulsified as I continue to whisk, now all I need to do is pour my finished dressing on a salad and enjoy. Thanks for watching and listening to me explain the emulsion formation and non-enzymatic browning reactions that took place while making this vinaigrette.